Good morning. Today we are going to see about design of steel structures. So there are two types of design. First one is functional design. The purpose. It may be a ventilation, lighting, aesthetic, and space utilization. And another one is for structural design. The structure is designed for its safety and checked for its serviceability, like RCC. Steel structure also designed for its safety and checked for its serviceability. The common steel structures is commonly every day we are using steel structures. We are preferred mainly because of the high strength and lightweight. The best example is where large span is required in case of roof truss, factories, cinemas, and auditoriums. In case of industrial buildings, cranes, girders, and columns. And then best example is all railway stations and bus stations roofs and domes, bridges. So best example is all railway bridges. Also the main part is the member subject to tension. The tension member is the best example for tension member is the transmission towers is the best example for including the cables. And apart from these, steel tanks, steel water tanks, and storage structures like bunkers and silos. So these are the common steel structures. And advantages of steel structures: high strength, speedy constructions with the prefabricated components, easy strengthening by welding, adding sections. So dismantling is possible when compared to all things are when compared to RCC, reinforced cement concrete structures. And then water and glass resistance if the joints are provided properly. And the best advantages is it is reusable. And the major disadvantages is corrosion, and it requires periodic maintenance, and the material is little expensive. And then types of steel. Before that, what is steel? Steel is alloy. Alloy means it's a combination of two or more material. A steel is alloy of iron and carbon. In addition to that, we can add manganese, sulfur, and phosphorus, chromium, nickel, etc. So first one is carbon. The function of carbon and manganese, it will increase the tensile strength of the steel. Also it will reduce the ductility. Also, in the addition of sulfur and phosphorus beyond 0.06 percentage, so imparts brittleness and decrease weldability and fatigue strength. And the purpose of chromium and nickel: improve the corrosion and high temperature resistance. Apart from these, in addition of copper, enhance corrosion resistance. So by slightly varying the chemical composition, you can get various types of steels are manufactured. So next one is structural steel. What is structural steel? It is classified into two types generally. First one is mild steel, another one is high strength steel. Conforming to weldable quality, may also be used provided the permissible stresses and other design provisions. So steel that is not supported by the mill test result may be permitted to be used for less important members where their properties such as ductility and weldability do not affect the performance requirements of the structures. And properties of steel, there are two types of properties. First one is physical properties and the second one is mechanical properties. Physical properties are thermal expansion, the same thing available in the IS 800 2007. Another one is density. Density of RCC is 2500 kg per meter cube. So like the density of steel is 7850 kg per meter cube. Also the modulus of elasticity is 2 into 10 power 5 Newton per mm square. Also the Poisson ratio of steel is 0.3. and the shear modulus is 0.769 into 10 power 5 Newton per mm square. And the mechanical properties, come to the second one. In the first one we looked into the physical properties, and second one is the mechanical properties. The mechanical properties such as yield stress, ultimate stress and elongation, and then notch toughness. So expect for notch toughness the other properties so also determined. So next one, the meaning of rolled steel sections. So like concrete steel sections of any shape and size cannot be cast on site. So normally in RCC all the members casted at the site, but since the steel needs very high temperature to melt and roll it into a required shape. The meaning of rolled steel sections, all the members so melted and roll into the required shapes. So after that you can get the different forms of steel. The first one is beam section. Another name of beam section is I section. The first one ISJB, Indian Standard Junior Beams, and ISLB, Indian Standard Light Beams, and next one is ISMB, Indian Standard Median Beams, and then ISWB, it is Indian Standard so wide flange beam, and ISHB, Indian Standard Heavy Beams. And the channels are like beams, that is Indian Standard Junior Channel, Indian Standard Light Channel, Indian Standard Medium Channel ISMC, and ISSC Indian Standard Special Channel. And an angle, there are two types. ISO mean it is Indian Standard angle. There are two types. The first one is equal angle, another one is unequal angle. And then like I beams, channels, angles. So T's are classified into three types, that is ISNT, ISHT, and ISLT. So like bars also classified into two types. First one ISRO, it is rounded bar. Another one is Indian Standard square bar. And the tubes, so we have three types: light, medium, heavy, based on the thickness. And then plates, flats, it is classified based on the thickness. So these are the examples for the types of steel. The first one is I section, the another name of I section is beam section, and the channel section, and the third one is it is a T section. So in that angle section we have two types. One is equal angle, this one is equal angle, another one is unequal angle. So next one, rolled steel tubes, it is classified into three types: light, medium, and heavy. So based on the diameter, so we are classified into three types. So and then thickness of rolled steel plates start from 5 to 18 mm. So and then next one is the width of the same plate start from 160 to 2500 mm. So and then special considerations, the design of steel. The following special considerations are required in the steel design. First one is the size, and then shape. Main purpose we are designing for the buckling. And the third one, minimum thickness, so it is essential for corrosion. And then third one, connection designs. The first one is size and shape. We are using them standard size. Steel is manufactured in the steel mills and is available in the certain shapes and size. Hence, the number of steel structures should be designed to consist of any of the available sections. And then sometimes the choice of the sections of the governed member by the shape of other members. And then special consideration in steel. So the first one is, so look at the figure, the first one is standard I section. So in that standard I section, another name of I section is beam section. Additionally, we are adding two plates on both the sides, top and bottom. The name of the section is built up sections. So conventional existing I section, additionally we are adding two plates, that is built up sections. And then buckling, what is buckling? So first one is buckling considerations. The permissible load per unit area in steel is much higher compared to the permissible values in concrete. So therefore, for same load, the cross-sectional area of steel member is smaller. As the member in a steel structures are more slender, slender means it is a long member. The another name of slender means the slender about without any braces. The compression member in steel structures are liable to buckling. So in case of beams, so there are chances of lateral buckling. Lateral means it is a horizontal load, so which creates special problems. So as a steel member consists of a number of thin plates, the stability of each part is to be considered. To account of buckling phenomena, code specify parts of sections be taken as ineffective. And then the second criteria is minimum thickness. The corrosion needs special consideration in steel design. If very thin sections are used, a small amount of correction may result into large percentage reduction in effective area. Hence, design practice specify minimum thickness to be used in structural members. And then main purpose of design, so need for connections. The steel design is not complete if the following connections are not designed. The first one, connection between various standard sections for a member. The second one, connection between various members like beam, column and foundations. The types of structural components, the first one is there are three types: riveted connections, bolted connections and welder connections. First one is riveted connections. It is absolute one, rarely used, so it can be used for non-structural members. And then bolted connections preferred for structural assembled on site. And welded connections, the IS 800 2007 recommendations by IS 800 2007 for monolithic strength. And then types of load acting on structures, like RCC, the first one is dead load, it is a permanent load. So we are taking from IS 875 part 1. The another one is temporary load. It is another name of temporary load is imposed load, that is live loads. The jib of crane is the boom loads. Next one is snow loads, dust loads, and hydrostatic and earth pressure, lateral pressure below the, for example, the member subject to below the ground structures. So another one is impact load, horizontal loads on parapets. So next one is wind load. So because the structure is light in weight, you must consider wind load. Another one is based on the seismic zone map of India, you need to consider earthquake load also. So next one, erection load. It's a temporary load. It is a temporary loads during erection of prefabricated elements. And then apart from these loads, additional one is, that is accidental load. So from collision, explosion and fire, it's unexpected load, that is accidental loads. And then the last one is secondary effects. So differential settlement, eccentricity and rigidity differences. And then as per IS 875 part 1, you can get dead load of materials. It may be asbestos or brick masonry and steel. And then live load means it is a temporary load. You will get live loads of members based on the purpose. You will get, in case of kitchen, dining hall, you will get it from IS 875 part 2. And there are 12 load combinations. So shown in here, the 12 load combination, dead load plus imposed load or wind load, are already discussed in the previous slides. So there are 12 combinations. And then structural analysis, there are 4 types. The first one is elastic analysis, second one plastic analysis, and the third one is advanced analysis. and the last one is dynamic analysis. Elastic analysis means, like RCC, the members are stressed well below their elastic limit, that is elastic limit. So we are not taking any risk. So we are designing the below the elastic limit. So further it is classified into two types. First one is first order analysis, another one is a second order analysis. So that's all about, there are four types: elastic, and then second one is plastic, and the third one is advanced analysis. So the last one is dynamic analysis. And then another name of the plastic analysis is yield analysis. An advanced analysis for frame with full lateral restraints. So full lateral restraint means so laterally fixed. So for this case, advanced analysis is required. So and then it is provided the analysis can be shown to accurately model the actual behavior of the class of the frames. The analysis shall take into account the following. The first one, relevant material properties, residual stresses, geometric imperfections, reduction in stiffness due to axial compression, second order effects, erection procedure, interaction with foundations. So, and then last one, the dynamic analysis is to be carried out in accordance with IS 1893 part 2. So that's all about design of steel structures. So today, we are looking into design of steel structures, the advantages of design of steel structures, disadvantages of design of steel structures, and then definition for rolled steel sections, also the types of steel sections, and then the common forms of steels. In addition to that, the methods of design of steel structures. So that's all about design of steel structures. Thank you for watching our video.